For joining our special spring edition of the Department of Soil, Water, and Climate seminar. I want to thank Kenneth Blumenfeld from the State Climate Office for coming today. He's going to give us the latest and greatest update on trends of climate in Minnesota. I know I'm going to benefit from this a lot. I'm going to take some of these nuggets to my class next week. So thank you, Ken.
Good. Well, thanks. Thanks, everyone. I hope you all can hear me online because this is what we got. So thanks for your hard work on this print. My name's Kenny. I adjunct faculty in the department, and I work in the State Climatology Office directly below this room for the Department of Natural Resources. And okay, I'll go back over here.
And that one.
There we go. All right. Let's see if we can. All right. So today we're going to talk about Minnesota's climate. We're going to talk about how it's been getting warmer and wetter. And if I sound 20% faster than I should, we're trying to make up some time. We've gotten warmer and wetter. We continue getting warmer and wetter, even though we've had dry conditions this decade. And of course, normal variability or the ups and downs, which I don't need to describe variability to this group probably, but most of my audiences need that. That variability remains central to our climate. So we will swing above and below any given trend line for a year or two or periods of years. The dry period that we've been in, we don't know if we're out of it yet, but during this decade is a real departure from where we had been, and it shows evidence of a continued wet trend. That is an odd statement. We also have increased snowfall, but declining snow depth. I think another kind of odd statement. And we're going to take a look at some crude fire weather trends too, because I've started looking at fire weather for some of our friends in forestry. And all of these are kind of vexing, somewhat contradictory points. And I'm a state of Minnesota employee who has access to the Microsoft 365 account, which means lots of stock photos, and I want to give taxpayers a return on their investment. That cat is unhappy with these statements about the dry early 2020s showing evidence of a continued wet trend. That seems like nonsense to this feline pal. There's not enough time to cover everything here, so we're going to dive in. All right, so let's just go for it. This graph shows every year on record from 1895 through 2025 in Minnesota. And we're taking the combined statewide average temperature and the statewide average precipitation. And then we are comparing those values to 20th century averages, which are those gray axes right in the middle. So this is basically departures from 20th century averages. On the left, you have cool years. On the right, you have warm years. On the bottom, you're dry. On the top, you're wet. Upper right quadrant is your warm, wet quadrant. We can't tell what any given year a particular dot is. That's because we have decided that the axes are going to be temperature and precipitation. But we can go into the database and figure it out. And all of these red ones in the upper right quadrant, those are the combined 10 sort of warmest, wettest years on record. Note that all of them have occurred since 1998. So we have 131 years of data, but the 10 combined warmest, wettest years on record all occurred in the last 28 years. Go ahead and figure out the statistical probability of doing that by chance. It's low. Really, really, really low. This is one of the ways that we know a fundamental shift is underway in our climate. Now, it's because we have variations and we have ups and downs. It's not that every year is warm and wet. We can see 2019 here, which was the wettest year on record. And you see 2025 barely made it into the upper right quadrant. And that's, again, we're just comparing it to 20th century averages, not more recent normals, which would use the 1991 through 2020 averages. But you have to go back you have to go back 4 decades, 4 complete decades to find a year that was actually down here in the cool and dry quadrant. Every other year since, I think it was 1986, has been either wet or warm or both. So we have a systematic shift towards warmer, wetter conditions. We have plenty of, warm, dry years here recently, obviously during the drought years, the 2020s and at other times, but we have definitely shifted. When we talk about what's going on with our climate, I think we all have to remember, I mean, I work with a lot of scientists and, we get so used to reading papers and sort of remembering the main talking points that it's easy to forget some of the kind of basics of how our climate works. So our climate is naturally extreme. We have huge swings in our annual temperature, right? The highest temperature in summer in even northern Minnesota is often in the upper 90s Fahrenheit, close to 100 degrees. And then you're going to drop down to -30, -35, maybe -40. Fun fact, that's Fahrenheit or Celsius when you get to -40. But that's a large temperature swing relative to other parts of the country, most other parts of the world. Certainly areas surrounded by water or near oceans don't have that kind of temperature variation. We also have a pronounced wet and dry season in Minnesota. Summer is 4 times wetter than winter. So we have a naturally extreme climate. We also have high variability, which is this rather intuitive aspect of our climate. If you've lived here long enough, you know that the winter you had last year is probably not going to repeat itself next year, or that the summer of one year is not going to be duplicated to the next year. You're going to get something different. And even if you get 2 very similar years, then the third one in that sequence is probably going to be off. And that's the nature of variability. We have high variability. So even though we have an extreme climate, even though we're prone to fairly warm, humid, short summers and long, cold winters, we also have a lot of variation in the behavior of those winters. And we have a lot of hazards. We have an unusual number of hazards. We get tornadoes and blizzards, we get floods, we get drought, we get heat waves, we get cold outbreaks. And any of those things I just named, maybe not the drought, but any of those other things could harm you. We have a lot of dangerous weather hazards. And this makes my job challenging at times, because as the climate changes and weather extremes become maybe not the rightful, but a logical kind of the logical poster children of the changing climate, people often look to these hazards and extremes as evidence. And this can make things difficult because here in Minnesota, we've had a moody climate already. So what does a tornado really tell us about the way the climate is changing? What does a big snowstorm tell us? What do floods really tell us? As everyone in this room and online knows for sure, you have to really dive into the data to assess some of those things. By the way, that graph, this could be just about anything. The graph on the right, it happens to be summer precipitation departures from 20th century averages, but it's just to show the inherent variability that's built into our climate. Even though there are some trends in there too, you still are swinging up and down below whether it's a trend line or some kind of average value. Then, of course, we've had incredible warming of the planet. So you have to layer these things on top of each other. You take a place that has a naturally extreme, variable, and hazardous climate, and then you remind yourself that it's in a world that's warming, where we're retaining more heat. And it's not quite year after year, but it's, over time, it's a very clear trend. Obviously, the majority of the warming globally has occurred in the last 5-6 decades. And sure, everyone's aware that 2023 and 2024 were the warmest years in the instrumented record on the planet. And if you open up some of the paleoclimatological studies, I mean, where you start, you don't maybe have as many sources of data and as much coverage, you could make some cases. You've got tens of thousands and possibly hundreds of thousands of years since it's been as warm as it was in, say, July of 2023 or September of 2023. Again, that I think you lose some statistical robustness with some of those comparisons, but in any case, it's been extremely warm, and certainly the warmest it's been in our lifetimes. And as a reminder, this means that a typical place will have more access on average to that additional heat. I mean, it's funny because water vapor is a form of heat. It's just stored heat it's the latent heat that's stored in water vapor. So it's kind of redundant to say heat and water vapor, but that's how most people understand it, right? You've got sort of the sensible heat of temperature, the kinetic energy of the temperature, and then you have the stored heat in the water vapor. And because evaporation increases as a function of temperature, the rates of evaporation off of our oceans always increase whenever global temperatures rise. And so you end up with more water in the atmosphere, meaning a typical location is going to have, on average, more access. At least there's more availability in any case of both heat and water vapor. So for Minnesota, what that's meant, because we don't have any barriers between us and the oceans, what this has meant is we've gotten warmer, gotten more humid, and we've gotten wetter on average, right? Lots of variability. All of the users of climate information who aren't scientists in Minnesota think in imperial units. So we're stuck with those for most of the data that I have here. But Minnesota has warmed by an average of about 3.5 degrees Fahrenheit to 2 or so degrees Celsius, going back to 1895. There's a stronger warming trend as you move farther north. This is a latitudinal effect. It's actually consistent. It's totally consistent with how greenhouse planets work, where you have a stronger greenhouse effect at higher latitudes. And because we've enhanced the greenhouse effect, it makes sense that we actually see a stronger response as you get closer to the poles. And we see this in Minnesota, not just on the annual average, but winter nights, the coldest time of year, the fastest warming time of year, where we have substantially more warming during winter nights than we do for just the average annual average, and certainly more than we have on some summertime days, which really only show almost statistically significant increases in northern Minnesota, not significant increases in central Minnesota, and not significant decreases. In other words, summertime temperatures in the southern 2/3 of Minnesota during the afternoons are basically holding steady to where they've always been. They're certainly not showing signs of increasing the way that they are at night in the winter. This is also, I mean, at least partially an artifact of the greenhouse effect combined with some other feedbacks. I should just show that the graph on the right is the highest dew point temperature. We can take our dew point record at an hourly level, at least back to 1903, at the 18th hour or 6 p.m. Central Standard Time. So we actually have that value back for over 100 years. So we can make a nice assessment of how much humidity and intense humidity has changed at that time of day. And the highest dew point temperature shows what is now just crossing the threshold of becoming a statistically meaningful trend. It just in the last few years has done that, but we do see an increase. And this is tied to how it feels also. It's also tied to how much moisture is available for precipitation. So no big surprise. Every part of the state has been wetter for the last 26 years. That's 2020 through 2025 than it was for the whole of the 20th century. The increases are more subtle and more reduced in northern Minnesota, where it's 3 to 6% increases in annual precipitation, but they're quite pronounced in southern Minnesota, up to 15% more precipitation falling now than in the 20th century on average. And that's including this dry period. We still have, it's not remarkable, but we still have a positive trend, meaning suggestion towards increased precipitation over the last 5.5 decades or so in Minnesota. There was really, wow, that was
Taking up time there.
yeah, made up a lot of time. Let's go back. In the first 70 some years of the record, there was really no trend. We had a wet period, we had the extraordinary drought of the Dust Bowl, and then we returned to kind of a benign climate. And it's really after 1970 that we saw persistent increase, even when you consider the variability. And what's interesting about the last several years is, those of you can see that there's a really high spike. That's 2019, right before this big drop off. 2019 was our wettest year on record. And then we just plunged off of a cliff. And it's been very dry, and we've had a lot of drought episodes. But I want to make a comparison. Take the driest year of that period, 2021, just fit a line across, and all those dots below that line are years that were drier than 2021, which turns out to only be the 29th driest year on record in Minnesota. Remember the cat that was unhappy with one of my statements? The dry period of the 2020s is the wettest dry period we have on record. So we can see trends towards increased precipitation even through the dry years that we have been experiencing. This is just another way of, we've got 58 stations that have good data for 7.5 decades. And we can do a comparison of all 58 of those stations and just say, okay, who has the highest annual precipitation value of all those stations each year? And just track that value, the highest precipitation, annual precipitation anywhere in the state. It's increased. That number has increased by an average about almost 8.5 inches. That's a whopping increase. And the 1940s and 50s did have some dry periods, but these are some wet years in here too. It's just this persistence. The wet years getting wetter, the dry years also generally getting wetter. We can look at the heaviest rain that falls on a single day anywhere in the state among these 58 stations. We had to do we have actually had students working hard on some of these analysis, and we made them test all the data and make sure that there's the correct proportion that are present and not missing. And so now we've got this pretty robust data set that we can just analyze the heck out of, and we see that the heaviest rainfall day, even when you account for the last several years where the heaviest rains are somewhat depressed in recent times, we still have an average increase of about 11%. I don't want to know what it's going to look like when we come out of this dry period, because there's more water vapor available to fuel these thunderstorms that lead to these events. And as you can see, prior to this dry trend, we just had an increase in the frequency and the magnitude of our most extreme rainfall events. So basically, by any metric, you could look at rainfall values across those same 58 stations that fit the NOAA Atlas 15 definition of a 10% annual rainfall event. That would be 10% probability in any given year. This is also a 10-year storm. And there's been a general increase, almost a stair-stepping increase the last several decades. And of course, we are low here. These are average annual values during the 2020s. We're a bit low because we've been dry. But note that in these 6 years, we're actually as high as any other decade had been prior to the wet trend. So we're getting, even though it's dry, we're still getting kind of a historically, at least average or above average number of heavy rainfall events. All right, so this is courtesy of both MCAP and also the University of Wisconsin Center for Climate Research. And this is essentially looking at the same thing, but spatially. So on average across Minnesota, a 10-year rainfall would be about 4 inches in a 24-hour period. And this is kind of a 30-year average of that kind of rainfall taken. It's a little bit out of date, but it's not going to affect the map dramatically. But what I need you to imagine is that this whole pattern on the left image had already shifted up to the northwest from the previous 30, 40 years. So if you went backwards 30 or 40 more years, you would see the lighter greens advancing farther southeast because these kinds of events weren't as frequent. And the projections, and this is just one of many, many projections, this is just kind of an easy way of looking at it, basically shows the trends that we've already experienced would continue, so that just imagine off to the southeast, there's a wetter, more intensive hydroclimate with bigger precipitation extremes, and we are importing that pattern from the southeast. And it's kind of spreading northwestward across the state. And so you end up with a 50 to 75% increase in these events, which still in the middle of the century and even at the end of the century, they'll still be rare-ish. I mean, you can double the frequency of a rare event and you still have a pretty rare event. But doubling that frequency has huge implications for hydrologic engineering and related purposes. So it shouldn't surprise us that in the last several decades, as we've gotten generally more precipitation, that the areal coverage, frequency, and severity of drought, this is one metric we could look at a lot of ways, has shown a long-term decline. I mean, and I should have updated this through 2025. You get a little bit more spike here on the right side, but all of these spikes are basically lower than the big historical ones. There's a downward trend on every single item we could look at in here. If we want to look at the most intense category of dryness, this D4 equivalent, or if we just want to look at D0, where you've got kind of pre-drought conditions, all of these are showing decreases in coverage, in duration, and frequency. Now, drought's interesting. If you look at climate models, we get really confusing signals, and I think with good reason, because we are getting warmer. And I think we might hit some kind of pivot point where this switches directions. But for now, the signal's all wet. We've just been getting wet. And, I don't want to cast too much shade on this, the recent dry periods. I mean, they've been intense. It's been hard for some folks. We've had creek beds like Minnehaha here just completely empty out in some of these episodes. And that's been a pretty common sight in the 2020s. And it was something, if you could imagine the opposite of that in the 2010s, that's what it was like in Minnesota. The greatest climate station in Minnesota is out in Milan. It's in west central Minnesota. It was 3 generations of observers. The most recent 2 observers just passed. But so far, there's still observations happening here. We can look at the lowest temperature of the year of winter, and also at the combined average of the 15 lowest temperatures of winter. And these all show increases because we're absorbing more long wave radiation in the atmosphere. So the long wave radiation, the heat is not escaping to space the way it would have if there were fewer greenhouse gases. So we retain that heat and the temperatures rise. Therefore, we don't get as cold as we used to. What now seems cold, like -33 Fahrenheit, if you look left, that used to be pretty common. And former extremes are values that we just don't see anymore. No surprise, we've shortened our winters. Our freezing seasons are generally shorter, but there is a lot of variability around that, right? I mean, so we have had the first freeze of fall arrive an average now of about 9 days later than it did at the beginning of the record at Milan. That's substantial. That's over a week. But we still have years with, you know, very early freezes. You can see those downward spikes. And the same is true on the backside of the season, what we're approaching now, where, you know, the final freeze of spring is now coming 2 weeks on average earlier. Across Minnesota, the whole freeze season is 2 to 4 weeks shorter than it used to be. But there's plenty of variation around those figures, even, you know, on a year-to-year basis, whether you're looking at the beginning or the end of the freezing season. Folks probably know we've lost a lot of ice cover period on Minnesota lakes, and we've had some challenges with ice quality, but we've also had some years that were really good for ice cover. This year has been good, generally. You know, we had some folks falling in, but that's winter in Minnesota. The winter of 2023, 2024 seemed to have a whole slew of lakes that had less ice cover than any other lake at any other time on record. So that was a very, very warm winter. And that was, of course, to take our trend towards warming climate conditions, and you throw a big El Nino event on top of that. And that's usually how we break these kinds of records. So somewhat surprising to a lot of our users, you know, the laws of thermodynamics don't stop in the winter when it's maybe harder to understand that there's moisture in the air, but we're seeing increases in moisture in the air in the winter time. We've set all kinds of precipitable water records during the cold months. And that means that there's more precipitation available or more moisture available when a precipitating weather event comes to town. And so we've actually seen increases across the state in snowfall, even when you include the last couple really poor years for snow. And, you know, this one finishes poor too. It's going to tweak that trend line down a little bit, but we're still showing long-term increases in snowfall. And if we count the number of days with heavy snow, so these would be days with 10 centimeters of snow or 4 inches of snow falling. And we look at our 5 long-term first order climate stations where we've got good metrics. And you see those bars generally getting taller, meaning we're seeing an increase in frequency over time in heavy snowfall events. But that red line corresponds to the temperature axis on the right. The snowfall season temperature between November and April, because that's our true snow season, has increased by several degrees during that time. So we get more snow, we get more heavy snow, it's warmer. No surprise, more moisture available with more warmth means more winter rain. So we have more days where it rains in the winter. In Duluth, the frequency of winter rain is 2 to 3 times higher than it was several decades ago. Still not super common, only, you know, a few days out of winter, maybe 4 or 5, but on average, but that's a big increase over what had been typical. And this is true across Minnesota. And so we have heavier, wetter snow. We have more moisture content in the snow. And in the 3 winters ago, that led to a lot of damage to our forests and to some structures because the snow was so heavy and contained so much moisture that the branches of these trees and some of the trees themselves just couldn't stand it and end up having probably the largest tree mortality event on record in winter in Minnesota. And it shouldn't surprise us that with warmer conditions and more rain falling on the snow, that even though there's more snow falling, we're having a harder time keeping that snow on the ground. So our average snowpack depth has declined by a quarter in Duluth during the winter time, the core winter months. Fun reminder for how these things are related. The ice albedo feedback is real. It's real on a day-to-day basis. So if we take all of so this is Wolf Ridge, which is basically the snowiest site in Minnesota for the cooperative network stations. And we take winter only. We've got 31 years of data that we looked at. This was another kind of student project helping out and a volunteer project. If you look at the days with no snow on the ground. And there were plenty of them. They've had their share. The average temperature is 26 degrees and change Fahrenheit at Wolf Ridge. You put 1 inch of snow on the ground, and the average temperature drops by almost 7 degrees Fahrenheit. You put 5 inches of snow on the ground, and the temperature drops by 10 degrees Fahrenheit. Now, I just want to point out, this is not a surprise. Don Baker, in his Climate of Minnesota publications with Dick Skaggs and some others, they looked at this exact question and found that the difference between snow on the ground and no snow, and particularly several inches of snow and no snow, could be the difference of 15 to 20 degrees Fahrenheit. So this isn't a surprising finding, but it's wild to see the statistics, and it's wild to see the fit of that line through the scatter plot. I mean, this is a strong physical response. You have snow on the ground, it's not going to get as warm as when you don't. And meanwhile, our summertime high temperatures not increasing yet. All right, so we're getting all this warming in the wintertime. The highest temperatures of summer are they're not showing it just yet. Projections are interesting because they show this massive increase in hot days as just a few decades from now. And as climatologists, we always wonder, okay, well, why aren't we seeing that yet? And we think, I mean, we're working with some of the modelers to try and get to the bottom of this, but I think one of the things that's happening, and this is bad graph, and I apologize for it. We're looking at 3 different variables. We could cut out the black line. The black line is, so remember I said I've got 6 p.m. readings all the way back to 1903. So we can actually calculate the heat index by taking the dew point and the temperature on those days. And so, but it's that 6 p.m. Central Time or 7 p.m. Daylight Time heat index value. And when we look at the highest one of the year, there's actually a pretty good positive trend. So heat index is going up at a much faster rate than the temperature at that time is going up. And there's really almost no trend with the temperature. This is not a statistically meaningful slope. But the dew point also has a stronger trend. So it's the moisture increase that's actually making it feel hotter. And remember, that's heat. There's more heat in the system. If you have high temperatures and high humidity, you've increased the total heat in the atmosphere at that location on that day. So we think one of the things that's happening is there's more humidity making it feel hotter, and the trend is already underway. And it'll be a little easier to get to this math if you just change temperature to heat index. The change is already underway. We're already seeing some of the highest heat index values on record, whereas we're not doing that with air temperature. This isn't a problem for this group here, but I do have a lot of audiences that are general purpose and they don't need all the graphs and the maps. And so I say, if all of that confused you, here's what winter warmth looks like. And this is what it looks like when you have too much moisture and precipitation fall. All right, so I just want to quickly go through some of the things I've looked at for fire weather in Minnesota, because I got to go to a prescribed burn council meeting a couple months ago, really interested. And they're having some challenges with prescribed burns. And these are similar, but kind of an opposite side of what's happening with the people who are trying to control fire and fight it. And so there's kind of a muddy picture. So we've gotten warmer, but we're not really hotter, right? We have more moisture around. Our average temperature is increasing. We're less cold, but we're not, by most metrics, hotter, even though, those extremes of heat index are going up. There's more moisture around in general. We have higher humidity. We have less overall drought, right? We have the normal ups and downs that are part of our climate. But of course, rising temperatures should increase evaporation. And we haven't even factored in, I don't have the ability to factor in ecological stress as you push certain species on the landscape out of their comfort zones. And so they're more susceptible to mortality or morbidity and the effect that that has locally on vegetation. And then what about seasonal differences? I mean, we didn't really account for very much of that at all. And I'm trying to help people who, want to do prescribed burns and also control fires have an understanding of where we're going. So this is all kind of preliminary, I would say. I mean, everything I show is preliminary. So let's just start. We've got spring, right? We have 2 fire seasons in Minnesota. Spring is the most prolific. I wish Pete were here, but it's, maybe it's 3 to 1 or 2 to 1. Spring is a more prolific fire season. Spring's getting wetter. Okay, spring is actually, on a statewide basis, we've got a pretty good trend towards getting wetter and also not getting warm that quickly in spring. So it's interesting. Our temperature trend in the last, total temperature increase in the last 50 some years is, during spring is not that remarkable. It's like 2/3 of a degree Celsius, roughly. It's not huge. And so we are getting warmer, but this isn't where the action is, right? If I showed you the same graph for winter, it's, we've gained 5 or 6 degrees Fahrenheit. Fall precipitation is decreasing in Minnesota. So if you put these things together, right, you'd say, okay, well, Minnesota, if it's just based on precipitation and temperature, Minnesota's, well, we're getting wetter, but we're also getting a little bit warmer in the spring. Maybe it's a wash. I'm not sure if I'd expect more fire conditions just based on that. And then you look at fall, which is getting drier since 1970, much warmer. We've also had, this is just this past year. I love making graphs that nobody understands when they first see them. But then you look at it or you read it and you're like, oh, wow. So we took back to Milan, which has this great long-term record. How many streaks where you get 10 days or more of 85-degree high temperatures, which is summer-like conditions? We could look at all of these. We've got them all, but then I just wanted to look at the ones that happened late in the season. All right. So each dot represents one of those streaks, and then its height on the vertical axis is the length of that streak. And the x-axis is the day of the year that it ends. And we had an 11-day streak that ended this year on October 5th. It was fully 3 weeks later than any other summer-like streak on record at that station. So we've had summer pushing more aggressively into fall. We know from our phenology friends that leaf drop and peak colors have been delayed. On average, there's variability in phenology too, but we have dropped about 2 weeks from our peak fall color date now. So it's 2 weeks later on average, with record lateness this past year, tied for record lateness this past year. And this is from Minnesota's premier naturalist phenologist, Jim Gilbert. It's looking at trees all over his area in Carver County. So then I thought, well, let's try and look at some hourly data and get a sense of when we actually would expect fire weather based on temperature, humidity, and windiness. I know that's what fire weather is driven by. You want to have low humidity, you need high enough temperatures, and you need sustained winds that, 15 miles an hour or greater. Usually you have gusts on those kinds of days too, and that helps kind of further dry things out and then fan the flames when something ignites. And we know that there's a reason for our fire season being stronger in spring than in the fall. You have more of these warm, humid, dry days, warm, dry, windy days in the spring than in the fall. Pretty big difference. This is Twin Cities, that's Eau Claire. Same thing in Duluth, same thing in Rochester. The early sort of fire weather conducive season is much stronger than the late one. Now, if we count the number of days actually satisfying the thresholds in the Twin Cities, there's no trend in the spring. So spring in the Twin Cities, even though we have our urban heat island, is not showing much. It's a very slight increase in the prevalence of days that satisfy this sort of warm, dry, windy criteria. And in the fall, there's a bit more of an increase. You've got pretty low overall numbers, so it's easier to drive a trend. You probably want to use a non-parametric statistic here, but in any case, there's something. There's a lopsidedness with more values on the right side of the graph that are elevated here. So our fall appears to have at least some trend towards more of this kind of fire conducive weather. You look at Eau Claire, it doesn't make any sense at all. We're having more of these warm, dry, windy days in the spring and more in the fall. When we look at Duluth, there's a decrease in the dry, warm, windy days in the spring, but an increase in the fall. And we look at Rochester and kind of an increase both seasons. So to recap that, both Minnesota, I don't need Wisconsin in there. I started this with a bunch of Wisconsin data, but Minnesota's getting warmer and wetter on average. We have warmer winters, more extreme precipitation, more snow and less snow cover. And a lot of these changes really took off in around 1970. I mean, in Minnesota, you do a change point detection technique and you're gonna hit 1970 within a few years on multiple variables. So that's kind of neat. So you can see a lot of that trend since that time. Springs have gotten wetter, falls are warmer, drier, and hotter. We've had these summers encroaching into fall's territory. So fire weather days seem to be increasing both seasons, but especially in the fall. So this is an interesting dynamic. The prescribed burn people really want that spring burning. I mean, this is what I've learned. I have 1 to 2 days worth of knowledge on this, so I don't know very much. I'm certainly not an expert, but my understanding is they want to burn in the fall or in the spring because there's all the leftovers from the winter. Let's burn it off. They're used to having good conditions for burning, and that they're not getting as much of that, and they've been challenged recently. In the fall, which is kind of a less optimal dry prescribed burn period, has some value, seeing big increases. And there, some of the problems that we're hearing from land managers is that in the periods of extreme drought, when you've had a lot of evaporation and a lot of moisture loss, some of the areas that they would burn are on peatlands, which you can't, they're worried about them totally igniting and never going out. So that's kind of a new issue that they're dealing with. And we've also heard some of them talking about how, they simply can't get a fall burn in because the leaves don't drop until it's too late. The leaves drop and then there's snow and you can't burn a snowy landscape. So trying to make sense of this has been interesting. I don't have any major conclusions beyond, we already did this. Beyond what I've discussed. Here y'all are. Thanks for, you can wake up now. Appreciate you putting up with me, and we got a few minutes left, so I can take questions if anyone has any.
Thank you, Kenny. Kenny, quick question. You said the fire weather maybe not changing that much or increase, but what is the actual fire frequency for Minnesota?
So the fire frequency is hard to know because we don't have great historical records, and the fire management techniques change too, right? I mean, what's really wild is that there's still a suppression mindset amongst many of the firefighters, but then you have the prescribed burn people who are like, we're going to blaze things now. And so it's hard to know. When we dig in with our fire weather forecasters at the DNR, there aren't any signs that we've gone hyperactive in the last several years. We know 2021 was pretty busy. Everyone got super nervous last year with that early start and the fires up in St. Louis and Lake counties. There's April, I think they started. But it ended up being a pretty unremarkable fire year here. But it was a banner year in Manitoba and Saskatchewan, and so we got to choke on that every time the winds blew from the northwest. So there's pretty good information suggesting that Canadian fires have increased in frequency and severity, the western fires, but Minnesota.
There's a number of global studies now
Yeah.
where linking the increased forest fire or fire frequency to increases in vapor pressure deficit.
Right.
Which in Minnesota, as you showed, we're having the increase in dew point temperature.
Right. So
Maybe helping.
good point. Yeah, I mean, I think most of the things we look at when, when we look at Pete's pan evaporation out in the field here, we're the number of cloudy days, most of our moisture metrics still show us getting wetter.
Yeah.
And that the dry years that we had recently are not standing out historically as being spectacularly dry. They're really kind of showing the same signs of being kind of in the lower middle of the pack historically. We haven't had any eyeball popping statistics from the pan in the last few years, which you would have maybe expected. But thanks, Tim. Great question and comment.
Can I have a question about that emergence of trends since the 1970s? There are plenty of different things people point to for the emergence of that. Like coming from out west, changes in the Pacific Ocean, sort of mid-70s, or
the big flip of the PDO.
Yeah, including things people like to point to say that it's all natural variability and climate change. But it's also fairly well timed with clear emergence of globally average warming observations too. So what do you say?
And I think additionally, there was some policy changes with the Clean Air Act, which might have made it easier to get more solar radiation down to Earth where we could have had a response.
Yeah.
So it's hard to know. I mean, we know that there's not an immediate response. If you put greenhouse gases in the atmosphere, it's going to take a while to accumulate them before you can measurably detect a change. And I think, so if you just take the graphs at face value, you'd say 1970 is when that happened. And I think if we didn't have high pollution emissions prior to 1970, like if our emissions had been cleaner, maybe we would have detected that increase earlier and we would have been in rougher shape now. We had a similar thing. I'm sure folks have read about how global shipping policies changed right in the late 2010s, and virtually basically every large freighter had to move to like a low sulfate fuel. And there's so many, we don't comprehend how many ships are sailing across the ocean, but so many that when we had the big warming spike in 2023 and 2024, a lot of research showed that, there was a contribution from the Hunga volcano of a couple of years earlier that still had a lot of water vapor in the atmosphere that was probably related to some heat retention. We had the El Nino, and then there's this effect of cleaning the fuel from ships that would actually have a net warming. So I can't say I know exactly what's driving it, but I'm going to go with the big signal is that we've accumulated enough to be able to detect around 1970, with the caveat that if the pollution had been cleaner, the emissions had been cleaner, we maybe would have detected it earlier. And if the emissions had been dirtier or we didn't have good policies, maybe it would have taken longer to detect. But it's kind of all there. Thanks. Great question.
There's a question in the chat
Okay.
from Nick. Many community folks I've talked to this year seem to have a perception that we've had a particularly cold winter. But I think that is mostly perceived by a few cold snaps and otherwise average or warmer than average winter season. Do you know where this meteorological winter ranks in terms of average temps relative to the historical record?
Yeah, great question. Thanks, Nick. The December through February winter ended up being warm for Minnesota compared to not just the 20th century averages, but also compared to the recent normal of 1991 through 2020. Not massively warm, because it is true, we actually spent a lot of time in December and January being pretty cold. And we thought, just based on December and January alone, that we were probably going to end up with a cold winter. But February showed up. February went ablaze. I mean, February was very warm and it overcompensated and kind of threw the winter over. And, you know, I just want to say too, we have to sometimes be humble. Data is great for scientists to understand science, but a lot of people, like Nick's talking about folks in the community, I think the same is true with a lot of farmers. They're not necessarily relying on data for their understanding of things. And while that can cause some problems, I try not to be in the business of arguing with someone's feeling with data. Like, it seemed like a really cold winter. You're wrong. It was actually warmer than normal. I think, you know, so I think there's validity in multiple directions to that observation, even though factually it was actually a pretty warm winter. But, you know, averages are kind of silly too, because they take all of the variability and they mush it into one number. I mean, we had some wild swings this winter. I was amazed how much warmth we had each of the winter months, even though we also had some really substantial coldness. And that's with the asterisk that what's cold now was not even noteworthy 50 years ago. But still, what we experienced January 23rd, that was a legitimately cold day by recent standards. So,
I just had my intro weather and climate exam. I gave them the weather versus climate, the climatology so far this year into the first half of February, and I asked them to describe the latter half of January, trying to get them to say it was cold, but not record cold. And I had one or two that was like, well, it was the beginning of a warming trend because I had the first half of February there as well.
Yeah,
So I had one or two who noticed that.
that's a good point. Yeah, Jess.
Yeah, I would, well, back to, you know, from a, like an adaptation or how we think about our changing natures, like the cold and then warm fluctuations all the time, like what do you make of that? Cause you can't, feels like it's a lot harder to prepare for, cause you can't just like bundle up for winter. Cause all of a sudden you have ice instead of snow, or you have to get back out your light jacket instead of your warm jacket,
Yeah.
all of this variability happens.
I guess I would say that winter has in general been less dependable. We've had some phenomenal winters. I mean, if you like snow, if you like generally cold conditions, we've had some great winters that were actually really consistently, you know, colder than they were warm. But you can't depend on those happening anymore. And so the winter of 2022-23 was, I would say, I mean, almost a snowfall paradise, and it almost like too much of a good thing. It broke a lot of stuff. But I mean, there were trails.
Like 2 great years screwed up people's
There were
expectations.
I mean, I remember one of the DNR trail reports was like, nobody can use the trails. There's too much snow on it, but the wolves are having at it. And then the next year it didn't snow. You know, we had, we've had winterless winters in the past. And we've had winters that kind of failed to sort of live up to the typical standard of a Minnesota winter, but those are becoming more common now. And we just can't depend on a good winter. Or you get into a period where it seems like it's a good winter, and then just that pattern breaks and you end up melting all your snow. We did that twice this winter. And, you know, and then I don't know how people will retain that information. We preserve it climatologically, but, you know, you condense your memory into a single data point, into one thing. And so it's unlikely that someone's going to remember this winter the way that I do. Where I say, well, you know, we had a lot of variations as we, you know, started out cold and then we're warm by the holidays and then we got cold again in the end of January and then February took off. People are going to remember it, you know, as icy or something like that. So thanks, great question. One more?
Yeah, it's kind of building on Jess's, with and talking about the variation in snow cover, specifically in like the insulation that can provide for soils and potential overwinter crops that you don't get in looking at an average, but you feel the variation where you might get a warming event that melts all the snow, and then before another precipitation event, a really, really cold dip. Is that something that we're seeing increasing? And that seems that's a variation that could be really damaging a lot of issues.
That's a great question. I can't tell you if there's a trend towards that. Sometimes I am susceptible to my own observations, which are anecdotal. Sort of, I don't want to conflate that with the trend. I think it's something that we saw this winter, right? And it's familiar enough from at least a couple other recent winters. I don't know if there's a trend towards it. There's some things that are really hard to find trends on because it's kind of a very specific configuration. Like, has there been an increase in the number of days where there's a thunderstorm and then a blizzard within 2 days after that? And like, that's tough. It's hard to find some of that. I think though that as our winter climate in particular warms, I think that the days with no snow cover are going to be they're already more common and will continue being more common. The days where you kind of are almost shocking the system out of one state into another seem like they could increase, but we'd have to look more closely at the data, and I'd have to refer to other people with their expertise to give you a better answer. Thanks. Thanks, everybody. Oh, okay. One further question.
All right, yeah. I saw you compare the trend with other states like Wisconsin. Did you compare those results with other states and not nearby the Great Lake?
Okay, so basically, our trends are similar in shape to most other states in our region, particularly the east. So, because the whole country's getting warmer and everyone's getting warmer winters. So that's one you can just blanket. You can just blanket everyone with that. And basically, Mississippi River on east is getting wetter too. So we have similar trends, but because we have more temperature variability than Michigan or than Ohio, the shape of our trends are a little bit different. The slopes are a little different and the relative change is a bit different, but they're pretty much changing in the same direction, getting warmer and wetter. When you go west into the Dakotas, some of that falls apart because they don't benefit from the access to moisture that we have. And so sometimes they just get warmer and not wetter, and then they evaporate more water out of everything and they end up drier. And so once you get into the middle of even just west of the Red River, the temperature trends are the same, but the precipitation trends start wobbling a little bit. And as you get farther west, we look less and less like those states from a hydroclimatological standpoint.
So can I understand that the main reason has come from the hydrology part, like the stream or the lakes?
I mean, so we get our moisture, we get when there's precipitation,
Yeah.
usually it's because our moisture comes off of the Gulf. Usually. There are other sources of moisture. We do get some from the Pacific Ocean too, but the Gulf is a big source of water vapor for us. And so that's because there's no real obstacles between us and the Gulf, and the wind coming from that direction is a pretty normal thing to do. But as you get farther west, the moisture sources are farther away and they require more unusual wind trajectories to deliver that moisture in. And so they just don't have the same access. And so you hear about with global climate changes, you hear about wet areas getting wetter and dry areas getting drier. And it really all comes down to access to moisture. It's the same story as everything with the haves and the have-nots getting more or less based on what their existing predispositions. If you're predisposed to receiving moisture, you're probably getting wetter. And if you're predisposed to being cut off from it, you're probably getting drier. Does that help at all?
Yeah,
Okay,
okay.
thank you.
Ken, one final question
Yeah.
before we go. Would you say that the Minnesota trends right now are enhancing overall agricultural production?
I don't know because there's so many other factors. The question is, are the trends in Minnesota enhancing agricultural production? There's so many other factors, crop genetics and strategies and management, nutrient management, all that. But certainly it hasn't been hurting.
Yeah.
Big crop yields have generally been increasing as in recent years and decades, generally. I think we just hit records in 2025. So for corn.
Yeah.
So thanks, everybody. Appreciate it.
Thank you.
Thanks for figuring it out. We made it. We made it. Thanks. Big hand from Brent Williams.
Thanks, Kenny.
Thanks a lot. See you, Peter. Thanks, Hannah.
You need the water bottle to match your seminar.
Oh, beautiful. Great.
Yeah.
Good swag.
This is like quite possibly the best swag I've ever gotten in my life.
My favorite one is from the Minnesota Council of, it's like counties and towns. And it's a mug with every county name on it.
Oh, wow.
wow.
I'm just happy to have a water bottle that has a water cycle.
I mean, the one I just described is ugly, but it's neat. It's really ugly, but it's neat. All right.
Kenny.
Yeah, thanks a lot. Thanks, everyone. Better crowd than I would have expected. Gonna disconnect here on Zoom.
So you mentioned several times, working with